Hi, let's talk for a few minutes about momentum and collision. To do this, we're going to take a look at some definitions and then some examples. Remember, this is a brief overview. If you would like more detailed information, I recommend you look in your text. Let's start with definitions. First of all, momentum. Momentum is the product of the mass and velocity of an object. Well, a simpler way of putting that is that momentum is mass on the move. Now, an object that has mass and is moving is said to have momentum. This momentum can be changed if you apply an impulse. So impulses are what change the momentum of an object. When objects are moving and have momentum, if they interact with each other, it is called a collision. So a collision is an interaction between two or more particles. This could be a truck hitting another truck. This could be a ball in a hand. This could be something striking the floor. But an interaction between two or more objects. When this occurs, it happens in two ways. It is either elastic or inelastic. In an elastic collision, there is no loss in energy due to deformation. Now, what is deformation? Deformation is the permanent changing of shape of an object. In an elastic collision, the objects spring back, if you will, to their original shape with no loss in energy. Now, the opposite of that would be an inelastic collision, where there is loss of energy due to deformation. Now, with these terms in mind, let's take a look at some examples. Momentum, mass on the move. When I think of momentum, I remember sportscasters saying, going into this championship, the Brighton Bengals have a great deal of momentum. This means that the Bengals are going to be hard to stop. Momentum, the symbol for which is a P, is mass on the move. So when we're thinking about it, I want you to realize there are two primary variables. There's mass, and then there's the on the move part, which is velocity. So momentum is the product of the mass of an object multiplied by its velocity. So, one way to think of this is to kind of picture it in your mind. Let's say that I have a truck and I have, a skateboard. Now, which of these objects has the greater momentum? Right now, the answer is neither of them has the greater momentum, because neither of them is moving right now. Momentum requires not just mass, but the mass itself has to be moving. So if we give the truck a little bit of momentum, if we give the truck a little bit of velocity, and we give the skateboard a little bit of velocity, which has the greater momentum? Well, the truck, with its larger mass, is going to have the greater momentum at that point in time as compared to the skateboard. Now, all of that could change if, let's say, we give the skateboard a great deal of velocity. The more velocity that we give, even if the mass stays the same, will eventually give the skateboard a greater momentum than even our large truck with its small velocity. Now, all objects that have momentum can have that momentum changed. This change of momentum is caused by impulses. So, impulse is equal to our change in momentum. What is it that it takes to change the momentum of an object, to speed it up or slow it down? Well, we're going to need to apply a force. And that force is going to have to happen for a certain period of time. So impulse is changing of momentum and it is equal to a force multiplied by a time. Now, some ways to think about that. How many of you have ever tried to catch a softball with your arms straight out in front of you and just tried to stop it as fast as you possibly can? Well, I guarantee you, when that ball hit your arm, you felt the jarring all the way down your arm, because your time was very, very small, so your force had to have been very large to cause that change in momentum. What I have observed from professional baseball players is that they don't stop the ball just with their arms straight, but they kind of curve their arm, and they allow the ball to fall into their arm as they're moving it backwards. Now, are they stopping the ball? Absolutely. That change in momentum, going from however fast it was going to zero, still happens. But the difference is the amount of time is much larger. Therefore, the force or the impact is going to be much smaller, because it happens over a greater amount of time. Another example might be if we have a car, and that car is going to have a change in momentum. Now, there are two options for how this change in momentum is going to happen. One of them is into a brick wall. The other one is into a large stack of hay. Now, both vehicles have the same mass, and they're both traveling at 30 miles per hour. So, the change in momentum is going to be the same. But, in the case of the car hitting the wall, the time is very, very small. Because once you hit that wall, that change in momentum happens all at once. Therefore, the impact or the force is going to be huge, crumpling the car, crushing the occupants. Whereas in our haystack scenario, the car is slowed down over a much, much longer time. That change in impulse is still, or the change in momentum is still happening. It still goes from 30 miles an hour to zero. But because the time is so much bigger, the force is so much smaller. The impact is so much smaller. Now, how does this tie to Newton's laws of motion? Well, first, Newton's first law of motion is called the law of inertia. Inertia says that an object in motion will stay in motion in a straight line and at a constant speed. An object at rest will stay at rest unless acted upon by an outside unbalanced force. This ties directly into our idea of momentum, because larger objects with greater speeds are going to have a greater tendency to continue moving. Now, this ties into Newton's second law, which says that accelerations are equal to force divided by mass. Now, this ties in directly because as we are looking at an object with momentum, if we are going to be changing that acceleration, we have to apply force, and it requires more force if we have more mass. Newton's third law, the law of action-reaction, ties in when we start talking about collisions, because for every action there's an equal and opposite reaction. So when car 1 impacts with car 2, the forces acting between them are going to be equal and opposite. So this brings us directly to collisions. Remember, I talked about the fact that there were two primary types of collisions. We have our elastic, and this is where things bounce, and our inelastic, where things stick. Now, the most important thing for you to remember when we're talking about collisions is that momentum is one of the few values that is conserved. This means that the momentum before a collision is going to be exactly equal to the momentum after the collision. even if other things have changed. So, key things to remember. Momentum is simply the product of the mass multiplied by the velocity. Momentum can be changed by impulses. And an impulse is our change in momentum, and it is equal to force multiplied by time. Newton's first, second, and third laws apply, and in particular when we're looking at collisions, we need to remember that forces in a collision are going to be equal and opposite. Also, keep in mind, momentum is conserved. I hope this helps. Have a good day.